Hello dear students, I welcome you all to my channel. So today's topic is on circles, and again we are going to learn a new form of equation and we call it parametric equation. Now before we begin with parametric equation, let's go back to what we have learned in the earlier session. For example, let's take standard equation of a circle. Now, standard equation of a circle contains two variables, that is x and y. Okay, and the other ones, that is h and k, they are constant, isn't it? Now similarly, if you move on to the general equation, that is x square plus y square plus 2gx plus 2fy plus c equals to 0, there also you see that there are two variables given to you, isn't it? But here in parametric equation, the variables x and y will be separated, and in this case we will form two different equations, okay, where x and y will be kept separately. Now what am I trying to say? Let's try to understand using this figure. Okay, so the figure is going to be shown shortly, but before, let's take the first case. The case one says when the center is origin. Okay, so we know that center can be origin or any other than origin, for example h comma k. Okay, so here I'm taking the first case to be when the center is origin. Okay, so let me show you the diagram. So as you can clearly see that the center is origin out here. Now let me take one point exactly on the circumference, okay, and that point is P, and the coordinate of this is x comma y, and let me call this OP to be the radius, and the radius is represented by small letter r. Okay, now from here what am I doing is, from here I am dropping a perpendicular PQ. Okay, now from this diagram what we can see is, we see that from here to here will be x and from here to here will be y. That's why my coordinate for P becomes x comma y. Okay, now same kind of figure you have already come across in your physics as well, where you have seen the resolution of a vector, isn't it? So if this is your vector and if it is making angle theta, in this case I am taking angle to be t. Okay, so if this is my t, then we know that the component of this along x will be r cos theta, isn't it? So let's see again the same thing out here. Okay, so we have cos theta equals to base by hypotenuse, isn't it? And if you see here, this is the given angle, so side opposite to this, that is PQ, is your perpendicular. This is my 90-degree, so side opposite to this, that is this OP is your hypotenuse, and whatever is left over, that is your base. So we know that cos theta is base by hypotenuse, so that's why base by hypotenuse, that is x by r, will be cos t here. So from here what do we get? From here we see that x will be r into cos t, isn't it? So this is one of the equation, and this t is called your parameter. All right, so if you see here in this equation we don't have y. Okay, so let's try to form one more equation containing y. So we see that sine theta will be perpendicular by hypotenuse, and what is my perpendicular? Perpendicular is y. Okay, so y by r gives me sine theta, that is sine t. So from here we have y equals to r sine t. So if I use these two, then these two gives me the parametric equation of a circle centered at origin. All right, so we have the parametric equation of the circle centered at origin is x equals to r cos t, comma y equals to r sine t. So basically x and y are separated here, and there's a common terminology used in both the equation, that is t, and this t is called the parameter. All right, now let's take the case when the center is hk. Okay, so let's go back to what we had learned in the initial phase of coordinate geometry. So if you remember something called shifting of origin, now what am I going to do is, since we already know what will be the parametric equation of the circle centered at origin, now what am I going to do is, I'll shift this h comma k to a new set of origin. Okay, that means this point becomes your o dash, if you remember your shifting of origin. Okay, so let me draw the diagram out here. Okay, so your new origin o dash, okay, and the point becomes p dash, x dash, y dash, and this diagram is similar to this, but only thing that will change is origin and the point. Okay, so for this point, what will be the, see, since this and this both are same, so that's why instead of x, okay, so instead of x I have got x dash, so in this equation also we'll write the same. Okay, so the parametric equation will become this much. Okay, but in our parametric equation we should not have x dash, we must have x, isn't it? And we know that x dash can be written as x minus h, isn't it? And similarly y dash can be written as y minus k using shifting of origin. Okay, so you take this h over there, k over there, you have this, isn't it? So this gives you the parametric equation of a circle centered at h comma k. So you may pause the video to note down. Now let's take the first question for the day, and in this particular exercise the sums are going to be very easy. So let's start with the easiest sum. So you need to write this as the parametric equation. Okay, so basically if you see this, this is a circle whose center is origin. Yes, so for any circle centered at origin, the parametric equation will be x equals to r cos t, y equals to r sin t. Okay, basically we need the value of only radius in this case, because t is a parameter whose value is not known to us and we need not find the value of parameter here. Okay, so the only unknown here is r. So the given circle is this one. Now if I write this in your standard form, then we can write this as x square plus y square equals to a square, where a becomes your root 13. And what is a actually? A is the radius, isn't it? So that's why we have center is origin, yes, and the radius, which is represented as small r, will be root over 13. So that's why your parametric equation will be x equals to r cos t, that is root 13 cos t, and y equals to root 13 sin t. So this will be your first answer. Okay, so let's go to the second question. So second question says find the parametric equation of this. Now again this is also given in standard form. Okay, and if this is given in standard form, for this your center will be, okay, so if you write this in x minus h whole square plus y minus k whole square, so you can write in this way. So basically this is my h and k is minus 3. So that's why your center will be 2 comma minus 3. Okay, and radius will be how much? It will be 6. So in this case, since my center is h comma k, so that's why x will be h plus r cos t and y will be k plus r sin t. Okay, so that's why my parametric equation will be h, that is 2, plus r cos t, and y will be k, that is minus 3, plus r sin t. Pause the video and note it down. Let's move to this question. So this is not given in standard form. Okay, so let's try to convert this into standard form, which you have not learned so far. So we will have a look at this sum very carefully. All right, so let's see. So this is given, yes, so we'll take everything to the left hand side. Okay, so if I take everything to the left hand side and divide both sides by 2, because I want the quotient of x square and y square to be 1. Okay, then I'll get this much. Now what am I going to do is I'll keep x together, all right, and y together. So if I do that, then we have x square minus 5 by 2x plus y square minus 7 by 2y, and we have minus 3 by 2 sitting separately. Now what am I going to do is I'll make use of this and try to form a perfect square. Similarly, I'll make use of these and try to form a perfect square. Let's see how to do that. Okay, so we have, see, what have I done is I have treated x as a. So we have a square minus, I have put 2 extra. Okay, so 2, and what is a? A is x, isn't it? A square minus 2. So that's why instead of here I'm writing x, because we have a minus b whole square equals to a square minus 2ab, isn't it? So that's why a square minus 2a is written. Now I have to put a number in such a way that I'll get 5 by 2. Okay, so obviously that number will be 5 by 4. So we have a square minus 2ab. So this is my b, so that's why I have put b square. Now this is extra, I have to balance this as well. Okay, now let's work similarly with this. So we have a square minus, okay, so let me write this as a square minus 2a. Now I have to put a number in such a way so that I'll get 7 by 2. So obviously that number will be 7 by 4. Okay, so we have a square minus 2a b plus, now we have to put b square. Again, this is also extra. Okay, so we have, let me take this minus 3 by 2 over there. So we have 3 by 2. Now in order to balance this 5 by 4 whole square, I put 1 more 5 by 4 whole square. Similarly, this is also extra. So in order to balance this, I put this here. Okay, so please be careful with this particular step. Okay, practice as many times as you can so that you will be able to do the other sums. Okay, so basically how much is this? This can be written as x minus 5 whole square, x minus 5 by 4 whole square plus, and this can be written as, this is a square minus 2ab plus b square. So this is a minus b whole square. All right, equals to, and if you simplify this part, you will get 49 by 8. Okay, so if you see here, this can be written in standard form where we have 5 by 4 as h and 7 by 4 as k. Okay, so x minus h whole square plus y minus k whole square equals to, now this can be written as this much. Okay, so please verify. So this becomes your radius. So what is the center in this case? Center is h comma k, that is 5 by 4 comma 7 by 4, and radius becomes your 7 by 2 root 2. So that's why in this case the parametric equation becomes x equals to h plus r cos t comma y equals to k plus r sin t. So pause the video to note down. Now let's have a look at the next question. So in this question, again the equation is given in general form. Alright, so in the last question we saw that in that general form we converted that given general form into standard form in order to find my h comma k, that is center and the radius. But we all know that we will be able to find the center and radius for general equation using the formula minus g comma minus f gives you the center, and square root of g square plus f square minus c gives you the radius. So that can also be used for finding the parametric equation. Okay, so we'll see this technique in this case. So the given circle is this one, and if I convert this into general form, then we have x square plus y square plus 2gx plus 2fy plus c equals to 0, where g is minus a and f is minus a and c is also 0 in this case. Okay, so we have h comma k, that is center, is given by minus g comma minus f. So minus g, and how much is g? G is minus a. So minus of minus a is a. Similarly, f is minus a. So that's why minus of minus a will be a. So that's why your center turns out to be a comma a. All right. So we got h comma k. Now let us find what is the radius. So radius is calculated using this formula. And what is g? G is minus a, isn't it? G is minus a, f is minus a, and c is 0, right? So evaluate this, you'll get a root 2. So we got the value of r, we got the value of h and k. So therefore your parametric equation will be x equals to h, that is a, plus r cos t, y equals to k plus r sin t. Pause the video and note it down. Okay, now let's convert the given parametric equation. So this is given to be a parametric equation, and we'll convert this into Cartesian equation. Now Cartesian equation means either you can convert this into standard form or you can convert this into general form. So basically Cartesian equation means equation containing both x and y. Here x and y are given to be separately. Okay, so if you see here, this is the given circle, right? And if you and we know that parametric equation of a circle centered at origin is given by this equation. Now if you compare 1 and 2, okay, then from this you see that the value of r is 2, isn't it? And from here we have r equals to 2, and we already know that the center is origin. All right, so that's why your Cartesian equation becomes x square plus y square equals to radius square. Okay, so this is the equation of a circle centered at origin with radius 2. That is, this will be your Cartesian equation for this given equation. Pause the video and note it down. Let's take the last question for the day. So this is the given parametric form, isn't it? So we'll convert this parametric form into Cartesian form. Okay, so we have this given to us. Now parametric equation of a circle centered at h comma k is given by this, isn't it? Now let's compare these two. So if I compare, we have h equals to -3, r equals to √7, k equals to 4, r equals to √7, isn't it? So comparing 1 and 2, we have these values. So that's why we have the equation will be x minus h whole square plus y minus k whole square equals to r square. How much is h? H is -3, k is 4, and r is √7. So put the value, so your answer will be this much. Pause the video to note it down. Thank you very much.